All right, how are you all doing? Because I've got a live demo, which isn't live, so it can't fail. So I'm feeling pretty good. But we're going to dig into this. So what I'm going to talk about is the literally recently published, as of Friday, HashiCorp Vault Enterprise marketplace solution. So it basically enables you to install Vault onto your Kubernetes cluster nice and easily. And then there's some features coming down the line which we'll kind of talk about, which will also make maintaining it a little bit easier. The demo I want to show you is predominantly centered around PKI infrastructure. So I'm going to show you how you can use Vault to generate PKI certs for your application workloads. And we're kind of going to be using Vault to generate those certificates. Now, the way that Vault can do that is it's got two different models. One is it can operate as a certificate authority, and the other is you can actually bring your own root CA. And that looks kind of like this. So Vault can operate as a root CA. You can have it create a sort of self-signed certificate. And then from there, what it can do is it can sign intermediate CAs, which you can then distribute to your applications. Now, those intermediate CAs are tightly controlled, so not everybody can access them. It's based around, well, in this specific demo, the permissions that the app has, and now those permissions are linked from the service account. So we can basically say that workload A can only generate a certificate called a.tld.com. Your other option is that you can actually use an offline CA. So if you've already got a root CA and you want to use Vault to generate those intermediates, then you can do that too. It's a sort of very, very flexible model. It depends on what you want to do. So, kind of as a quick sort of overview, this is some of the things that we're going to do. Now, before I dig into the demo, one of the things that you can also do, which can be important to some large sort of enterprise, specifically in a sort of a hyper-secure situation, is you need to generate either your keys, you're storing them in a certificate authority, or you want to use the entropy from a sort of an HSM or something like that. Vault can also do those integrations. Right. Lastly, if you want to use Acme, then Vault can act as an Acme agent as well, so you can kind of use your Let's Encrypt stuff from there. But I want to show you a demo. Now, this is not a live demo as such, but it's kind of live. And the way that I say it's kind of live is that I recorded it just 10 minutes ago. So it's live-ish. And I need to juggle some things around because this is a coded video, plan B, plan C style. We will get there. Okay, so what I'm going to do is I'm going to go through the steps here of setting this up. So we're using the marketplace. So I'm going to go into the marketplace and I create my I'm going to search for Vault Enterprise. And you can see the new published item here. So there it is. So I'm selecting this, and I'm going to create a new item from it. Now, this is Vault Enterprise, so it's bring your own license. We will add additional sort of capabilities to this. I'm going to use this item because I want to test out what's going on. So I'm going to create the resource group. I'm also going to get it to create a Kubernetes cluster for me. And that'll go through and it'll create all of those things. So let's log into Cloud Shell. And let's have a look at the application running. So I'm just going to have a look at the pods. So what I've done, the marketplace extension has installed Vault into the Vault namespace on Kubernetes. And it's set it up in a production environment, fully supported and highly available. But it sets it up and it's not initialized. So possibly. Yeah, I'll talk to you about that afterwards. So we're just going to configure this. So we're just adding the license because the license, it has to be read from a Kubernetes secret. And until the license is present, the actual server instance won't start. So we're just setting that up. I can tell you that this is live because I didn't edit out my typing mistakes here. I forgot to source my bash profile inside of Cloud Shell. It's live. It's live enough. It's like theater. So then the next step, what we're going to do is we're going to initialize Vault. And we've got to do this just once. This is kind of just the kind of that setup step. And I've got a script in the demo repo here, which you can kind of play with. But what we're doing is we're running this command Vault operator in it. That sets up Vault and kind of initializes the data store. And then those kind of keys which are generated, we're going to save those to the local machine. And the reason that we do that, we need to keep those keys very safe. So one is the unseal key for the data store, and the other is the root key. And as I said, this is literally unfiltered. It is like you are watching me make these typing mistakes live. So here we go. So we're now going to have a look at the pods, and we should see that the Vault server is, so it's running now. And then we run that initialization script. We get our Vault token that we can use to configure the cluster, and we've also unsealed it. So for a demo, like I'm not exposing Vault through a load balancer. Of course, you could do that. You could configure it to either use a sort of configure through an internal load balancer that you're accessing with a VPC, or you could actually use a public load balancer and then use client TLS to kind of, and obviously the built-in auth to configure. But I'm just going to use kubectl port forward to actually be able to get access to the cluster just for the configuration purposes. So that should just come up. And this is literally all done in real time. So we've got our Vault cluster up. Now, let's configure it. And let's configure it so that we can enable PKI. So what we're going to do, we're going to enable the PKI secrets engine. And then we're going to tune that because we're going to set the lease of the PKI secrets engine for a certificate for a year. Now, everything in Vault is based around a lease. And the reason is because we're dealing with time-based secrets. And a certificate is time-based. We want to ideally keep any secret to have a very short lifespan, as short as we can possibly manage. Because that way, if it then leaks, there's less of a sort of a blast radius. So that's configured the CA there, and I've just generated a self-signed CA and done that internally. And then what I'm going to do is I'm going to generate a certificate. So let's have a look at this. So the certificate that I can use to generate is this command here. And I'm going to generate a certificate which has the URI SAN is for app.marketplace.demo. And I do that through this command here, but this is just for demonstration. You'll see that when we run this in an actual pod, we don't need to kind of do this as a manual step. It's just a test that everything's working. So next step, what do we need to do? Now, Kubernetes needs to be able to talk to Vault to generate the certificates. Kubernetes, or the Kubernetes pod, your workload, has to have very specific control and permissions. We can't just let any workload inside of Kubernetes generate certificates or access any secrets. So we use the Kubernetes authentication, and the Kubernetes authentication uses service account tokens in order to control access to the secrets inside of Vault, or in this instance, the X509 certificates, because they are just a secret. And also, we need to configure the application's permissions so that you have the authentication and you have permission. But the job itself, it looks like this. So we're defining a service account. We are injecting the secret. So that's this magic source here. It's basically a Vault template which will create a certificate from Marketplace, and it will write it to the two files. And then all we're going to do is we're just going to reference those as environment variables for the application. This is one method that you can use to get your secrets into your workload. There is the Vault CSI operator, and there's also the Vault operator itself, where you can actually sync secrets between Vault and standard Kubernetes secrets. There's a few different ways to go about it. So we've applied that. Let's just wait for that. Well, it's already started. Yeah, so we can run it. And then we're done. So you can see that, well, let's just wait 2 seconds for it to come up. There we go. Everything's working. So we've configured the application. You can see there from the output that I'm just using OpenSSL to connect, which dumps the certificate information. You can see there it has the CN, and then also right down the bottom we have everything. And it's fine. Now, you're probably wondering, that is marvelous. How do I go about finding out some information on this? Grab this link. So the full demo is there. There's some more information there. And if you want to kind of talk to me, then feel free to either swing by our booth or just grab me and we can talk. And thank you so much. And sorry about... So you can't extend the expiry date on the certificate, but you can generate a new one.
We have to track it and we have to keep regenerating this.
Yeah, so you can do that. I can talk to you about that offline.